Hello and welcome. In this video, we'll explore the Softmax activation function, what it is, how it works, and the key properties that make it essential for multi-class classification tasks. The Softmax activation function converts a vector of raw outputs, called as logits, of a neural network into a probability distribution. In simple words, it takes any set of numerical values and scales them into probabilities between 0 and 1. Let's see how does Softmax work. We illustrate working of Softmax function using this diagram. Softmax performs its function in 3 steps. Firstly, the Softmax function takes the output of a neural network, typically a vector of real numbers called logits, which represent the raw scores for each class in a multi-class classification task. Then, each value in the vector is exponentiated using a mathematical constant e, about 2.718. This step makes all the numbers positive. Lastly, after exponentiation, each value is divided by the total sum of all exponentiated values. In this way, we have a vector of probabilities corresponding to logits as output of the Softmax function. If we talk about properties of Softmax, it has 3 key properties. Softmax ensures that all output values fall between 0 and 1, making them valid probabilities. As you can see here in this vector, all values are between 0 and 1. The outputs from Softmax always add up to 1, which is essential for interpreting them as a probability distribution across classes. You can verify that the output of the Softmax function sums up to 1, confirming it represents a valid probability distribution. By converting raw scores or logits into probabilities, Softmax makes the model's predictions more understandable and easier to analyze. Compare the raw output of the neural network with the output after applying the Softmax function. Which one is easier to interpret? Clearly, the Softmax output is more intuitive, as it represents probabilities for each class. Now, let's dive deeper into the working of the Softmax function by exploring its mathematical formulation and illustrating it with an example. Consider a neural network diagram which illustrates how the Softmax activation function is applied in the output layer to classify input data into one of 5 classes. Let's consider a real-world example of classifying fruits, for example, apple, banana, orange, kiwi, and mango. Suppose we want the network to identify these fruits based on 5 features. 1. Color, for example, red, yellow, green. 2. Weight. 3. Size. 4. Texture, for example, smooth or rough. And 5. Sugar content. These 5 features are fed into the input layer, which consists of 5 neurons, each one receiving a single feature. The data then passes through hidden layers, where the network learns complex patterns and feature interactions. In the output layer, there are 5 neurons corresponding to 5 possible fruit classes, producing the raw outputs or logits from this layer as 3, 1, 0.2, -1, 0.5 indicate the network's unnormalized confidence scores for each fruit class. Next, these logits are fed into the Softmax activation function, which converts them into probabilities. This transformation involves, firstly, exponentiating each logit or a raw score into a positive value. As shown here, the process starts by exponentiating the logit 3 and continues through to 0.5. This step is called as exponentiation. After exponentiation, all the resulting values are summed up to proceed to the final step called as normalization. In normalization step, each exponentiated value is divided by the total sum of all exponentiated values to convert them into probabilities. For example, the exponentiated value of logit 3, which is 20.0855, is divided by the total sum, and the same process continues down to the value 1.6487 from logit 0.5. This normalization ensures that all output values lie between 0 and 1 and collectively sum to 1, making them interpretable as probabilities. So, probabilities for each class are computed as apple, 0.771, banana, 0.104, orange, 0.047, kiwi, 0.014, a mango, 0.063. This indicates that the network predicts the input most likely corresponds to an apple with 77.1% confidence. In short, the 5 input features flow through the network to produce 5 output probabilities, and Softmax plays a key role in converting those raw scores into an interpretable prediction. That wraps up today's video. Please don't forget to subscribe our channel, like the video, share and comment it to stay updated with this series.